On problem number 1, notice right here it says which expression is equivalent to 2m to the 4th power times 5m to the 8th power. And so I'm going to go ahead and I'm going to show you a quick way to solve this problem by using the calculator. And then you could also use your exponential rules. So what I use on this one is I'm going to use my guess and check. So when I say my guess and check, I'm going to come over here to my scratch pad and I'm going to write down what I have. So for instance, right now I have 2, and then I have an m to the 4th power times 5m to the 8th power. Now you could do this by using the power to a power rule, but the guess and check method works really good on these. So when I say guess and check method, what I'm going to do is I'm actually going to replace this m with a number. And my favorite number to start with, that I always try first, I'm going to write it in a box, is to start with the number 2. If you have more than one variable, you can also use 3 and 4 and so on. But notice this one only has one variable, and it's an m. So I'm going to replace these m's with the number 2. For instance, I'm going to rewrite this as 2, and then in place of the m, I'm going to put parentheses, and I'm going to put a number 2 in there. In other words, what I'm doing at this point is I'm going to say m is equal to 2. So everywhere there's an m, I'm going to put a 2. And then it says to the 4th power, so this is 2 to the 4th power. And then right here I have 5, and then I have another m. So we're going to replace this m with a 2 as well. So that's why I'm putting a parenthesis here. And it's to the 8th power. So I'm going to put a power of 8. So what I want you to notice is I simply took this m and replaced it with a set of parentheses. I took this m and replaced it with a set of parentheses and put a 2 in place of m. And now what I'm going to do is I'm going to evaluate it real quick in my calculator. So I'm going to bring my calculator over. I'm going to turn it on. I'll go ahead and go to calculate mode. And I want to go ahead and I want to type this in now. So I'm going to go ahead and put in parenthesis, 2, another parenthesis, 2, close, and then hit my caret key to the power of 4, close parenthesis. Actually, let me click to the right and then close parenthesis. So it looks just like this, 2 times 2, which is replaced m with the 2, to the power of 4. And then times, and I'm going to put my next one. I have 5, parenthesis 2, close parenthesis, to the power of 8, and close parenthesis. So now notice I have it written, right, just like what you have here. And it's all numbers. I got rid of the letters. I replaced the m with the 2. I'm going to hit enter, and notice it gives me 40,960. So since this gives me 40,960, whichever answer you see on this screen over here, whichever one of these is the correct answer, if I replace m with a 2 and evaluate it, it should give me the same thing that I have over here, 4,960. So I'm going to do that right quick. So let me go ahead and go over here. I'm going to start with the first one. It says 7m to the 12th power. So I'm going to put 7m to the 12th power. Now if I want to go ahead and evaluate this right, I'm just going to replace the m with a set of parentheses, bring down my 7, bring down the 12, and I'm going to go ahead and put a 2 in here, right? Because we had replaced m right here with a 2. So if this is equivalent and it is the correct answer, it should give me the same thing when I put it in the calculator, 40,960. So I'm going to type in 7, parenthesis, 2, close parenthesis, to the power of 12. And notice this gives me 28,672. Those two numbers don't match. So I'm going to go ahead and put an X on this. It is not the first answer choice. And we're going to check the next one. So I want to go over here and I'm going to look at this 10m to the power of 12. So I'm going to try that one. So I'm going to go ahead and I'm going to write that. So I got 10 and I have m to the power of 12. So I'll put 10 parenthesis. And then for m, right, we're going to be replacing it with a 2. So put a 2 in place of m right there, and to the power of 12. And we'll see if this one's the right answer. So I'm going to put it in my calculator. 10 times 2 to the power of 12. And notice it gives me 40,960. So I know that this answer is correct. Now this is the trick to answer it. So I'm going to go ahead and select B. B is the correct answer. And what I want to tell you is, if you wanted to see another way to do it, the way where we use the actual rules of exponents, I'm going to show you that way next. But if you're satisfied with using the guess and check method to get it right, then go ahead and pause this video. And then what I want you to do is I want you to write a statement explaining how you solved this problem. And when I say how you solved it, if you solved it correctly, explain how you did. If not, you're going to explain how you saw me solve it. So I want you to go ahead and write a short explanation explaining how you saw me solve this, how I use this guess and check method. And then if you want to see how to do this the way that you really should be doing it, which is the power to power rule, I'm going to do that right now. So just continue to just watch this video. But if you don't want to learn that way, or you're satisfied with this guess and check, just move to the next problem. Now I'm going to go ahead and I'm going to solve this the way that it was intended to be solved. So I'm going to rewrite it. So I have 2 m to the 4th power, close parenthesis, and then I have 5 m to the 8th power. And if I wanted to follow the rules on this, my rules say that anytime I have these particular expressions being multiplied, then what I got to do is consider, am I going to need to do I have a power to power rule situation? So like, do we have a power on the outside of the parenthesis? Or is it just simple multiplication across and we have the product rule? And so what I'm going to end up using is the product rule, because I realized that at first initially looking at it, I did say power to power rule, I believe. But noticing right now looking at it, really this is just multiplication. So I'm going to rewrite this. This right here being multiplied is really like saying 2 times m to the 4th power times 5, because the parenthesis just means to multiply, times m to the 8th power. And the product rule says that anytime we're multiplying exponents, all we're going to do is add the powers. So what I mean by that is this power of 4 is going to be added to this power of 8, because that's the product rule. I'm going to write that right here. Product rule. Now, what I'm going to do is, before I add these two powers, I also want to put together any individual numbers I have. So for instance, I have a 2 and I have a 5. So I'm going to multiply those. So if you're not sure, right, if you're not good at multiplication, just get out your calculator and let it do the work. So I say 2 times 5, and it gives me 10. So I'm going to move this over, and I'm going to say, okay, so when I multiply the 2 and the 5, that gives me 10. And now I'm going to go ahead and use my product rule with my powers. I have m to the 4th, so I'm going to write m to the 4th power, and then I'm going to go ahead and add the 8th power to it, plus the power of 8. And if I do that in my calculator, I have 4 plus 8, and it gives me 12. So then at this point, I know that my final answer, when I simplify this, is going to be 10 m to the 12th power, because you add the 4 and the 8. And that's the proper way to do this. That's what's expected. But notice that the guess and check, it got us the same answer. So you can use either method, right? You can use your product rule to solve one of these. Now notice this one is the product rule, right? But maybe you have used the quotient rule, power to power rule. So it just depends on the situation. But if you remember your rules, you can do it this way, and I feel like it's very simple. If not, use the guess and check method and substitute a number of your choice. But I always prefer to use a low number like 2, 3, or 4. But don't use 1. Use 2 or greater. And then see which one of these gives you an equivalent value, because that's what we did. Go ahead and pause this video and then move to the next problem. Alright, in this problem here, I'm going to move this up. And draw me a line to separate our previous problem. That was for problem number 1. And what I'm going to do now is we're going to look at number 2. And notice it says the function of f of x is equal to x was transformed to form g of x is equal to f of x minus 23. Which statement is true about the graphs of f and g? Well, we have two different situations. So for number 2, what I'm going to do before I even try to figure out which one of these is true, I'm going to try to duplicate what they're saying has occurred here. So first of all, they said that we had an equation of f of x is equal to x. So this is my first equation. I'm going to write first right here. And then on the next problem, it says it was transformed to g of x is equal to f of x minus 23. So I'm going to rewrite that real quick. I'm going to do that one in pink. So g of x is equal to f of x minus 23. Now notice they're telling me that it's equal to f of x minus 23. And why this to me looks confusing, what they're really just saying is whatever this f of x is equal to. And this f of x right here was just simply equal to x. So I'm going to replace f of x with what it's equal to, which is x. So in other words, I'm going to substitute this function notation with the variable x, which is what f of x is equal to. And so really what I have is I have g of x is equal to x minus 23. Now the good thing about it is I can graph this first one, f of x is equal to x, and I can graph this second function, g of x is equal to negative 23, or minus 23 I should say, g of x equal to x minus 23. And when I graph both of them, we can go ahead and look at the picture, and I'm going to just draw like a sketch of it after I graph it in the calculator, and then we can compare it to these statements and see which one actually looks like it's true. So let me go ahead and put this in my calculator. Now remember, if you want to graph one of these, what you want to do is use the graphing feature down at the bottom. So I am going to go ahead and hit the home button. I'm going to go down to this very bottom one. I don't like using this one. I like the bottom one because the tab opens up automatically for you to be able to graph it. So I'm going to hit enter. Notice it says f of x is equal to, so I'm just going to put what's on the right side of it, which is x. So there's my parent function for linear equation. You can see it graphed. So now what I want to do is I want to graph the second one. I want to graph g of x is equal to x minus 23. Now to do that, I'm going to go ahead and hit tab, T-A-B. It pulls up a second function for me. Now it doesn't say g of x, but it's f of x. It's just the name of the function. And we're going to go ahead and type in x minus 23, because that's what g of x is equal to. X minus 23. I'm going to hit enter. And notice I didn't see the line. So I want to zoom out because we do want to see what this looks like. So I'm going to hit menu. I'm going to go down to zoom and go to out. And I'm just going to keep going out until I see the line. And now look, I can see the line. It's right here. So I'm going to go ahead. I'm going to hit escape so I don't zoom it out anymore. And I can look and compare the relationship. Now to me, I don't know if you noticed this, but those lines look parallel to me. Do you see that? Right? They are parallel, which makes sense because both of these, if you look, have a slope of 1, right? This being x, the m value is the number in front of the x, which is an invisible 1. The m value for this one is an invisible 1. So I'm going to draw both of my graphs. One of my graphs went through origin, the first one. That was f of x. And then the second one, it didn't go through origin. It crossed way down here at negative 23. And it was parallel. So this is my picture that I have in my calculator, and I'm going to use my sketch to help me see which one of these answer choices makes the most sense. So A says the graph of f and g are not parallel. Well, that's false, right? Because we could clearly see that these are parallel. I'm going to write that down. And when we have a parallel line, the definition of a parallel line is that there are two lines that do not intersect. And you can see on the calculator very clearly, these two lines never intersect. Another reason we knew it was parallel was because we know that the m value right here, the slope, is equal to 1, right? Because there's an invisible 1 in front of there. And we know that right here, once again, my slope, there's an invisible 1 in front of it, is equal to 1. So anything that says not parallel is false. So I'm going to go ahead and look at this real quick. And I'm going to say, you know what? This answer right here, let me see. is definitely going to be false right here. Now I'm going to go to the next one. The graphs of f and g are not parallel. Again, this is false, right? Because it is parallel. So let's go ahead and go to the next one. The graphs of f and g are parallel, and the graph of f is translated 23 units up. Okay, so they're saying that f of x, the black line that we drew, has moved up 23 units. But what I hope you notice is that we didn't move up 23 units. Our new line, right, g of x, what we transformed, actually moved down. So it can't be C because that says it moved up. So our answer, it has to be D, that GF and G are parallel and the graph of F is translated 23 units down. In other words, we went from being at origin all the way down to negative 23 for our y-intercept. We could also verify that if you wanted to. I mean, you can tell by looking at it that it moved down, so that's the only correct answer. But if we wanted to, right, we could actually go in here and I could go back to my image, accidentally clicked out, and I could hit Control and T. And when I do that, right, I can look and I can see my x-intercepts and y-intercepts. So notice we had a y-intercept at 0, 0 for the first function. The blue one, right, that's the first function. That's f of x equals x. And if I go over to the second function, its y-intercept is negative 23. That's what that means under the red one where it says x is minus 23. X is 0, and the y value is negative 23. So it is true that it moved down 23 units. Go ahead and pause this video. If you got it correct, explain how you did it, because maybe you did it different than me. If you got it wrong, well, then explain how you seen me do it correctly. You must do that in order to get credit for this activity. Pause the video, solve the next problem on your own, and once you're done with it, go ahead and hit play to see if you got it correct.
In problem number 3, it says a graph of a quadratic function is shown. What are the x-intercepts of the function? Select 2 correct answers. So notice I can go down here and click on these bubbles anywhere on it, right? And I can highlight them, but it only lets me pick 2. So we're just going to be picking 2 answers. And what I want you to do is I want you to think back to when we were dealing with quadratics. And when we dealt with quadratics, we graphed quite a few of these, and we did transformations on them as well. So let's go ahead and draw a graph. So our notes here, we're going to draw a graph. I do want to go ahead and label my axis. So notice I have this vertical axis that goes up and down. That's the y-axis. And then I have my horizontal axis that goes left and right, which is my x-axis. Now I'm just going to draw an image that looks similar to this one. It's just a sketch, so it's not going to be exactly like it, but it's going to be very similar. And what I want you to remember is when we have one of these quadratics that's graphed, in this case this one happens to flip down or open downward, which means its leading terms coefficient is going to be negative. I want you to remember that everywhere that it crosses the x-axis is an x-intercept, right? It just means that it touches it as it comes by. So I'm going to go ahead and label this right here, x-intercept. And notice over here, we also have a second x-intercept. Now, one last thing I want you to remember is they won't always call it the x-intercept. We talked about this in class. Sometimes they're going to call them your zeros, or they could call them roots, or they could be called solutions. But these are all the same thing. We notate them different, but they are where the parabola is going to cross the x-axis for Algebra 1. So keep that in mind as you're solving this problem. And if we look over here, right, while we can click on any of these bubbles, we want to click on the ones where it shows it crossing the x-axis, which is -1 and +3. These up here on top, notice that very top one, right, that would be your maximum or your vertex. The one down here on the left, that's going to be your y-intercept. It's where it crosses the y-axis. So the correct answer for this problem is right here at -1 and +3. Go ahead and make sure that you write down the notes for this problem and then write your one-sentence statement that states how it was solved correctly. Then pause the video and try the next problem on your own.
Okay, on this problem, notice question number 4. It says, an artist bought a set of 10 paintbrushes. Now, I know normally on the paper, right, my rule was that you underline keywords and you box all numbers and variables and equations. So what I'm going to do is I do want to go ahead and I want to highlight some stuff. So what I would do is if you come over to highlight a section, right, you can highlight it whatever color you want. I'm just using yellow for the first one. So we're talking about an artist got 10 paintbrushes and it says and that contained X small paintbrushes. Okay, so we have small paintbrushes and Y large paintbrushes. So then we have large paintbrushes. It says the number of small paintbrushes in the set was 4 times. Okay, so the small paintbrushes was 4 times. So I'm going to highlight it the same color that we did small. The number of large paintbrushes in the set. Which system of equation can be used to find the numbers of small paintbrushes and large paintbrushes in a set? So ultimately we're trying to find small and large. So now what I'm going to do is I'm going to go ahead and try to write this out before I approach any one of these equations. So here's what I know. I know that we have small. I'm going to do that one in red. That's going to be my X. I'm going to put X is equal to small brushes and Y is equal to large brushes. So just before I do any math, right, I just want to go ahead and write a note to myself. Now, it didn't tell me how many large paintbrushes we had, but we did get some insight of how many small paintbrushes we had. And notice it says the number of small paintbrushes. So I'm going to go ahead, I'm going to highlight that real quick. In the set was 4 times the number of large paintbrushes. So remember, anytime we hear number, you just put a variable in its place. So it's 4 times the number of large paintbrushes. Now remember, large paintbrushes is represented by the variable y. So if it's 4 times the number of large paintbrushes, then basically what we're going to say is that the small is actually going to be equal to 4 times y. Now, this looks a little bit different than in some ways that we've done. That just happened to tell me that the small paintbrushes are equal to 4 times y. So that's actually going to be one of my equations. So I'm going to write it. In other words, X has to be equal to 4 times my y value, which is the number of large paintbrushes I have. So this is one equation. Anything that doesn't have X equals 4y is going to be wrong. So let's see if we can actually strike some of these out. The first one, notice in A it says X equals 4y, so that's correct. B says X equals 4y, that's correct. C says Y equals 4X, so that's wrong. That's not true. So I'm going to go ahead, I'm going to do strike through real quick, and I'm going to strike through that one. Notice that D says Y is equal to 4X. That one's wrong as well. So now it's either going to be A or it's going to be B. So let's look at the next thing that we know. We know that the artist bought a set of 10, so they got 10 paintbrushes. Those paintbrushes are made up of small and large. In other words, X and Y. So the second equation that I can write from this is going to be X plus Y, and this just means my X is my small paintbrushes plus Y, my large paintbrushes, should be equal to a total of 10 paintbrushes. So this is my equation here, and if I come back over, notice B had X minus Y, so B is wrong. So the answer is A. X plus Y equals 10. That's small paintbrushes plus large paintbrushes equals 10 paintbrushes. And then X is equal to 4Y, because the number of small paintbrushes in the set is 4 times the number of large paintbrushes in the set. So what I want you to do is go ahead, and if you got it wrong, I want you to go ahead and write the way that you saw me solve it, which was correct. But if you got it right and you just did the process a little bit differently, go ahead and explain how you were able to get the correct equation. Right? Keep it short though. Just one sentence giving me a brief explanation of how you got the correct answer.